Okay, so the question we're going to answer in this video is, how do I find the domain of a radical function? And specifically, you can see on the screen, I'm going to work with a square root function. And at the end of the video, we can mention real quick some other radical functions. But the main problem that pops up when you're asked to find the domain of a radical function is that when you use this symbol, whatever goes underneath that symbol needs to remain a positive number, because if you end up with something like, for example, square root of minus 2, that's what we call a complex number. You may or may not have seen that one way you can simplify this is to write it with the letter I, as I square root of 2. So the point is that we cannot allow this. When we're talking about the domain of a function, we're talking about finding the real numbers that are quote-unquote allowed for the variable x, right? So this word indicates we want to find just the x values that will give us a real number. This number here is not real. So the point of all this is that whatever expression is under the radical, in this case it's 2x minus 7, it can't be negative, right? We can't ever allow 2x minus 7 to be negative. So we need to figure out what x values will prevent that from happening. So we're going to say 2x minus 7 is not negative. And if we're saying that that is not negative, then the only other option is that it's positive. Or could possibly be 0. And there's a nice mathematical way to express that. 2x minus 7 must be set greater than or equal to 0. Now if we solve this little expression, if we solve this inequality for x, then we will have found the x values that will keep 2x minus 7 greater than or equal to 0, or, in other words, not negative. So just a couple of quick algebraic steps. Add 7 and divide by 2. And that gives us the domain, and check with your instructor as to how he or she wants you to write that. A lot of times you want to put the inequality in interval notation, which is usually how you'll see it written. But that is the domain. So this process will work anytime you want to find the domain of a square root function. Now it turns out that this idea that we can't have a negative number underneath a square root applies to any even root. So if I took, say, this function, let's just make it easy, the fourth root of x minus 6, the same idea applies. We don't want a negative number under any even root. So 8th root, 10th root, 12th root, so on and so forth. So to find the domain of this function, we would simply say we know that x minus 6 must be greater than or equal to 0, and therefore all x values greater than or equal to 6. So in interval notation, 6 to infinity. That's the domain of g of x. Right, and then just to mention, you can also find the domain of an odd root function, so maybe cube root of whatever, something like that. Well, it's okay to take the cube root of a negative number. Say, for instance, the cube root of negative 8, we know, is negative 2, right? So we don't end up with a complex number when we do the cube root of a negative number. Same thing goes for any odd numbered root, 5th root, 7th root, 9th root. It's okay to put negative numbers underneath those. So for an odd root, like, there's no restrictions. There's no restriction on what's under the radical. It can be positive, it could be negative, it could be 0, it could be anything, right? No matter what you take the cube root of, you're always going to end up with some real number. It may not be easy to find, but it'll be a real number. And so the domain for any odd root function is always all real numbers or negative infinity to infinity. So those are the basics on how to find the domain of a radical function. Like I said at the beginning, most of the time you probably end up with a square root function, and you can find the domain of a square root function just like I did the very first example. So hopefully